Hello, hello, and welcome to a little video about the introduction to exponential and logarithmic functions. Let's start off with exponents. All right, so here's a very basic exponential function. Y equals 2 to the x. I want to point out a few things here. You should notice that this graph is getting flatter on the bottom, so horizontally, okay? It's actually getting really close to an asymptote. That asymptote is y equals 0, and I'm going to do my best to draw this out. I'm doing little dashes because it's actually invisible. Right? We don't see that line, but our y's, our outputs, get infinitely closer to 0. And here's a table to prove it. As I'm getting smaller on my x's, my y's are getting smaller and smaller. And you can even try it out. Plug in an even smaller x, you'll get an even smaller y. But we will never reach 0. It is impossible to raise 2 to the power of anything to get 0. Right? So it's not possible. We can't do it. So we can get really close to 0, but never reach it, which is why y equals 0 is our asymptote. Another thing I'd like to point out is the Y-intercept. Our Y-intercept is right here, and it's 0, 1. That's an important point to focus on because it tells us a lot about the graph. This Y-intercept could be moved up and down. It could also be moved left and right. When it moves up and down, my y's change. When it moves left and right, my x's change. But we're still going to be looking at this point, okay? And just to show you why this is a point that is important, 2 to the power of 0 is 1. 3 to the power of 0 is 1. Literally anything to the power of 0 is 1, which is why this y-intercept is such an important point. Okay, so that is the most basic exponential graph. Now let's transform it. Let's move it up and down. Let's move it left and right. Now, I have two graphs to demonstrate that. On the left, hopefully you see that from the original, this left graph moved up, and it moved up 1. One way we can tell is right here, this plus 1. That's up 1. Now, if we didn't have the equation, we can look at it differently. First, we can look at the asymptote. We can see what is it flattening out to. Here, it's getting closer and closer. Oh, I probably shouldn't use red there. Let's use a different color. It's getting closer and closer. Okay, I'm not the best artist, but it's getting closer and closer to y equals 1. You can tell that by this table. The smaller my x's get, the closer to 1 my y's get. No matter how small the x you plug in, y is going to be 1 point something, but it will never reach perfect 1.0. You can also tell by looking at this y-intercept. At the x's, we still have 0, so the x didn't change. My y changed. It went up to 2. So if we went from 1 to 2, that's up 2. Up 1. Whoops. Why did I say up 2? Oh, Miss Gumin. All right, let's continue to this example. Hopefully you can see that this graph was moved to the right. Now, you might not be able to tell how many spaces to the right, so let's see how we can tell. First, if we have the equation, we can tell by seeing a minus 5 in the exponent. That's right 5. Let's say we didn't have the equation, we had the graph. First, I can tell that we didn't move up and down because my asymptote is still 0. We're still flattening out at 0. And if I look at my table, the smaller my x's become, the closer my y's get to 0. Now, I'm looking for my y-intercept, and I know it didn't. And I know that my y-intercept for my original graph is 0, 1. And if we move left and right, my x's will change, but my y won't. So let's find that point, but transformed. Here it is. My y didn't change because I moved to the right, but my x did. That 5 should give away how many spaces we moved to the right or left, depending on what that is. So, once again, on our graph, I looked at my asymptotes to see if we moved up or down. I also looked at my y-intercept. If my since I figured out that this graph moved up. Maybe we don't know how many. Since it moved up, whoops, my y changed. So I look for x is 0, my y is 2. So if it's going from 1 to 2, that's up 1. In this graph, I'd say, okay, I know it didn't move up and down, so my 1 stays 1. And I take a look at my x is 5. That means I moved to the right 5. Let's write that down. So just standard form of this equation. If I have anything in the exponent, it means left, right, anything outside, up, down. So, all right, h, that's left / right. Left would be a plus sign, right would be a minus sign. K is up / down. Up would be addition, down would be subtraction. Oh, by the way, I wanted to point this out. Your K is directly, let's just type that out. Directly related to the horizontal asymptote. And what I mean is, if you take a look here, we went up 1, y equals 1. We didn't go up at all, y stayed the same. Let's explore logarithms. Now, it kind of looks like an exponential function, but not really. I mean, it does have the swoosh, but it goes a little differently. And it also has the flat part, but this time it's vertical. Let's see what that means for us. A vertical flattening out still shows us an asymptote, but this time we're going to have a vertical asymptote. And of course, my drawing isn't beautiful, but imagine that this is at x equals 0. That means this graph will get infinitely close to x equals 0, but we can never plug in 0. That is not possible. And if you couldn't tell from the image, take a look at the table. 0 and less are undefined. So we cannot go over here, and it's not possible. And we can't even be at 0. If you take a look at your x's and y's, we get pretty close to 0 over here. On our x's, at least. And we do hit 0 on my y's. That's fine. And we are getting slowly larger with my y's. As you can see, the curve right here is very, very shallow. What's the opposite of steep? It's a slow climb. How about that? It's a very slow climb. But it's slowly getting larger as my x's get larger. So we go to the right. We do have an intercept. This time, however, we have an x-intercept. So on my exponential, I had a y-intercept and y equals 0. On my logarithmic, I have an x-intercept and x equals 0. They're inverses of each other. Now let's take a look about moving this logarithm left and right and up and down. And we are going to look at the asymptote again. If the x's change on this x-intercept, that means we moved right and left, and we still have a y with a 0. If we move this graph up and down, our y should change, but my x should still be 1. So let's check it out. On this graph, it looks like, let me zoom out so we can see both of them. It looks like I moved my graph upwards, up 3. So, how can I tell from the equation? This plus 3 on the outside. If I didn't have the equation, first I look for the asymptote, and I see that it's still getting flat by 0. So let me draw that in. Which means I did not move left or right. Still x equals 0. So that means it moved up and down. In the original graph, my point is 1, 0. When we move up and down, my y's change. So I'm going to look for x is 1. Here it is, 1, 3. That means we moved up 3. Let's take a look at the second one. Here we have y equals log of x minus 2. Now, if we take a look at the original graph and this logarithm, hopefully you can see that it's been shifted to the right. Now, after we find out it's been shifted to the right, maybe we don't know how many spaces. Let's check it out. First, I look at the equation, if we have it. I have a minus 2. That tells me to the right 2. Well, let's say I don't have an equation. I look at this graph and I see that it's flattening out at 2. X equals 2. That should give it away. If not, then we take a look at the table. So since I know we moved right, my x has changed from the original x-intercept, but my y shouldn't. So I'm looking for where my y is 0. Here it is. X became 3. It was originally 1. That means I shifted to the right 2 spaces. Let's put that all in together in an equation. Y equals log of x minus h plus k. Just like before, h is about left and right, and it's still addition for left, subtraction for right. K is still up and down. It's still plus for up, and down is minus. In this case, however, h sorry, pause there, is directly related to the vertical asymptote. All right, and that's really all I wanted to go over with you in this lesson. We'll continue experimenting and moving around these graphs, but what I wanted to make sure to emphasize this time is the movements up, down, left, and right based on the equation, the graph, and of course, the relationship to the asymptote. In our exponential function, the asymptote was horizontal, which means it was a y equals. It was directly related to the part of the equation that moved us up and down, because that's what y's do. They're the vertical ones. They move up and down. In logarithms, we also emphasize the vertical asymptote this time, the movements left, right, up, and down, and of course highlighted the fact that our movement left and right is directly related to the vertical asymptote, because if you take a look at the x's, if you move left and right, it changes the vertical asymptote, the x equals value. All right, I hope that was helpful. If you have any questions, please feel free to ask me or your teachers. Have a wonderful rest of whatever time of day it is for you. Bye.